Hello, good morning. My name is Leslie Sabina Villaseñor Cerón of the Universidad Autónoma del Estado de Hidalgo. I am going to present antibacterial effects of hydroxyapatite synthesis by the hydrothermal method using sodium citrate and PVP. The hydroxyapatite is a bioceramic primarily utilized in the development of the biomaterials due to the inert properties such as biocompatibility and bioactivity. This make it an essential component in the fabrication of the products and the graft used in the bone repair surgeries. Evaluating the antibacterial activity is essential to the prevents bacterial adhesion on the plants and prostheses of graft. This study evaluated the antibacterial properties of the hydroxyapatite synthesized by a hydrothermal method with the sodium citrate and PVP as the surfactants. The methodology in the subsection A, the synthesis of hydroxyapatite sodium citrate, the synthesis begins with the dissolution of the calcium and phosphate precursors in deionized water. Subsequently, the calcium precursor is added dropping of the phosphate precursor, and the pH of the reaction is adjusted the 10. The solution is the transfer to autoclave and the synthesis at 200 degrees Celsius for 24 hours. And finally, the result precipitate is recovered, washed with the deionized water, and read at the 90 degrees Celsius for 24 hours. In subsection B, the synthesis of the hydroxyapatite PVP is present. Its methodology is similar in the subsection A. In this methodology is used and the microwave. The temperature is at 200 degrees Celsius for 30 minutes, and is the resulting precipitate is recovered, washed, deionized water, and is treated at the 20 degrees Celsius, 19 degrees Celsius for the 24 hours. And the samples were characterization using X-ray diffraction in the picture 2 and the picture 3 is show as the observed the formation of the monoclinical and hexagonal phase in the picture 2 and 4 show us enlargement of the spectrum, identity and displaying the coaction and the coexistence of the both fast this monoclinical and fast and hexagonal hexagonal fast. In the characterization for Fourier transformed infrared in the picture 5 and the picture 6, the spectrum corresponding to the hydroxyapatite samples and the different concentrations, the sodium citrates in picture 6, picture 5 is corresponding different concentration of PVP, and these spectrums corresponding showing the bands corresponding to the hydroxyl and phosphate groups characteristic of hydroxyapatite. Subsequently, in the picture 7, corresponding to the synthesis of hydroxyapatite with PVP, are showing displaying agglomerates of the order of the 1 to 7 micrometers in the picture 8, corresponding to the synthesis of hydroxyapatite with sodium citrate and agglomerates ranging from the 136 to 245 nanometers are observed. Finally, the antibacterial test in the picture 10 is corresponding of the hydroxyapatite with sodium citrate, and is interesting in the picture 10, corresponding of the hydroxyapatite with the concentration the 0.1 percent of the PVP is showing an bacterial inhibition halo and characteristic halo corresponding of the hydroxyapatite samples, the concentration 0.1% of the PVP. This conclusion, X-ray diffraction identified to the unique formation of hydroxyapatite with hexagonal crystal fast and monoclinical fast. Additionally, a reduction of the 46% was observed for the in the samples P2 with a PVP concentration of the 0.1% by weight for the sodium citrate samples. The formation agglomerates in the ranks at 130 to 215 nanometers, corresponding a smaller structure was noted. The antibacterial test conducted with the strength of the Escherichia coli and Staphylococcus aureus exhibit normal growth in the presence of the hydroxyapatite samples with the sodium citrate. The samples P2 corresponding 0.1% of the PVP contain of the Escherichia coli and Staphylococcus aureus string demonstrate the formation of the bacterial halo as well bacterial halo in the case of PVP. The samples P2 corresponding to the Escherichia coli strain exhibition the formation of the bacterial halo and bacterial halo. Thank you for your attention.